to find the length of a curve. All right, suppose you've got a curve f of x, and you want to know how long it is. Well, it'd be great if you could just take a little tape measure and just run it along there and just say, yeah, it's whatever long, but that's really not practical, especially if you have something that's really curly and going all sorts of ways. So you may say, well, let's estimate the length of this curve. Excuse me. And you might look at the end, pick 2 points, and you might draw a straight line and say, well, it's about that long, however long that is. But you know there would be a lot of error because it doesn't take into consideration the curve of that. So you may say, okay, we'll break it into smaller pieces. I'll look at this piece and I'll look at this piece. I'll take those and add those together. That's not very accurate, but it would work for a while. And then you say, well, let's make this smaller pieces. And you may do like this. And I think you can see the more little pieces I'm taking, the closer I'm getting to the actual length of the curve. Exactly. So we're taking a lot of very small pieces and we're going to add them together. And look at that as the number of pieces approaches infinity, which should sound like a limit, which should lead you to the idea of an integral. So if you want to know the length of this curve, if this were point A and this is point B, let's just say, then if you added all those up together, you'd get a Riemann sum. We're going to go straight to the integral. You would integrate from A to B, square root of 1 plus f prime of x squared dx. This is if you have a function of x. If you have a function of x, this is dx. These limits of integration have to do with x's. If your function is instead defined, no, I'll get it right, yeah. Say x is equal to g of y. And it could still look the same, but this is your function x in terms of y. Then the limits of integration, or the length, would be with respect to your your y-axis. So if you wanted to find the length of the curve and everything's in terms of y, then the length of the curve is going to be the length from C to D, the square root of 1 plus g prime of y squared dy. So you've got to have everything in terms of x's or everything in terms of y. Okay? Don't mix it up. All right, so if we have, let's just say, this is number 5. They want me to set up an integral for this function. Y is equal to x minus the natural log of x. As x goes from 1 to 4, they want me to set up the integral for the length of this curve and then use my calculator to find the length correct to 4 decimal places. Well, they've given me my function y in terms of x. These limits of integration have to do with x's. So all I need to do to go to my formula is to find y prime. The derivative of x is 1. The derivative of natural log of x is 1 over x. That's y prime. So my arc length is the integral from 1 to 4. These are with respect to x. The square root of 1 plus 1 minus 1 over x squared dx. And then all you have to do at this point is put this in your calculator. This is a proper integral. Be on the lookout for improper integrals. This one is proper because the only thing that would mess this up is 0, and 0 is not between 1 and 4. So this is proper, so you just do it like normal.
But if it's like negative 1 and 4, it would be improper?
It would be improper. You'd have to calculate it as a limit. Okay, I'm going to set this up. I'm going to assume that you can put this in your calculator. We'll go back later if you want to and check to make sure you get the right answer. Is there a question about that? This is a formula. All we're doing is using the formula. All right, let me see if there's one where I have x in terms of y. Maybe, let's see. Oh, I guess I could look at number 12. Number 12 says x is equal to y to the 4th over 8 plus 1 over 4y squared. My limits of integration are from 1 to 2. Y goes from 1 to 2. And this is my function x. And I'm just going to rewrite this for a second. I'm going to write that y to the negative 2 because I'm fixing to have to take the derivative of this. I need x prime to go in my formula. So the derivative of this is 4 over 8, which is 1/2 y to the 3rd minus 2 over 4 y to the negative 3. So that's 1/2 y to the 3rd minus 1/2 y to the negative 3. And that is my x prime, which is g prime of y. It's the exact same thing. So all I do now for my arc length, these are in terms of y, so this needs to be in terms of y, so I'm integrating from 1 to 2. The square root of 1 plus 1/2 y to the 3rd minus 1/2 y to the negative 3, all of that squared, dy. By the way, I hope y'all check my math. And then you put this in your calculator, and it says exact length, so do not give them a decimal, give them exact. They want an exact answer. So don't change your calculator to a decimal. Question about that one? Again, we'll look at this. All right, then another couple. Let me look at one real quick. This is number 21. And I just want to look at it because they set it up a little bit different. Y is equal to 1/2 x squared. They want the length of the curve from the point -1, 1/2 to the point Q, which is 1, 1/2. They want the length from P to Q. These are ordered pairs this time. All right, so what would be my first step? I have y is equal to 1/2 x squared. What's the first thing I probably need to do? For my formula, I need to, how about take the derivative? So y prime is 2 times 1/2, which is 1. So y prime is x. All right, well then I'm going to have to integrate. How do I choose my limits of integration here? They've given me ordered pairs. I use my x's, right? Because this is in terms of x. So I'm going to use my two x's, use -1 to 1, and the square root of 1 plus x squared dx. So you just choose the x's, yes.
So if it say x equals 1/2 y squared, you use the y?
Correct.
This is going to be an improper integral.
Which one? The other one would be?
This one,
No.
right?
Why is this not improper?
There's no x in the denominator.
There's nothing in the denominator here, so this is still proper. This is still proper, so you just integrate it like normal. This should be a smooth curve. Do I need to do what?
No.
Okay. 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 And then I thought I would look at one that's got some words in it because I've given y'all a couple